So we have a question here, which is a continuous beam ABC having a span with UDL. AB span is loaded with UDL 20 kN per meter load, and we need to find moment at B. So for this type of question, in case of continuous beam, we can use a theorem which is Clapeyron theorem. Clapeyron's theorem, which is moment at A into L plus 2 times MB moment at V L1 plus L2 plus moment at C L3. Sorry, this will be L2, right? This is L1 and this is L2, because there is only 2 spans, so this will be L1 and this will be L2, right? Equal to minus 6 A1 x1 bar divided by L1 minus 6 A2 x2 bar divided by L2, right? So what is A1, what is A2, x or x1 bar, x2 bar? So these are area of bending moment diagram, A1, A2 for another span, area of bending moment diagram. X1 bar is the distance of CG from support, right? So first we need to draw bending moment diagram. We will draw here bending moment diagram. For separate span we can draw. So AB span is loaded with UDL, and we know we will draw it. It will be parabolic with this coordinate having value of WL square divided by 8. So here W is 20, L is 6, L is 6 square divided by 8, right? This is about bending moment diagram. So if we now we need to calculate A1. A1 is the area of bending moment diagram. Area of bending moment diagram for section 1 for first span, which is AB. This is AB. So you have a parabola here, and area of parabola is 2 by 3 VH. So here 2 by 3 into B is 6, this is B, width, span length 6, so B will be 6, and H is the coordinate at center, which is WL square by 8, which is 20 into 6 square divided by 8. Now x1 bar, which is the distance of centroid from support. So from here and here we need to calculate the distance of centroid. So as you know, this is symmetric. There is a symmetry in this figure. So the CG will lie over the YY axis. So this will be at the center. So x1 bar will be 6 meter. Now comes A2 and x2 bar. A2 means the area of bending moment diagram at another span, which is BC. So BC has no load here, so there will be zero bending moment, so there will not be any area and there will not be any x2 here. So this will become 0, this value will become 0, and now we calculate. So here is MA L1, moment at A. So as it is a simply supported at A, so MA would be 0, so this would be 0 plus 2 MB, we need to calculate it. Now L1 plus L2. L1 is the length of span AB, L2 is the length of another span which is same, so 6 plus 6 will become 12 plus moment at C. Moment at C means this support will also will not carry any moment, so value will be 0, is equal to minus 6 into A1. Let's calculate A1 value from calculator. So I am using calculator, which is 2 by 3 into 6 into 20 into 6 square divided by 8. It has a value 360. So you can calculate, it will come 360, and so 6 A1 is 360 into x1 bar. X1 bar is 6 divided by 2, so this will become 3 divided by L1. L1 is 6. L1 is 6 minus, as this value is 0, it will become 0, right? So this is 24 MB is equal to, you can cut it, 360 into 3 is 1080, and when you divide it by 24, it will become 45. So 45 kilonewton meter. Now there is a minus sign here. See, there is a minus sign here. You will put minus here. This is also minus. So the value of MB, which is moment at B, will be minus 45 kilonewton meter. Minus means just again. So this is the problem of continuous beam using Clapeyron theorem has been solved. Thank you.